بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Today I'm going to present about the catalytic and the non-catalytic. Uh, Wait, let me share the presentation. Okay. Uh, okay, my presentation is about pyrolysis of polystyrene waste, which is a study on catalytic and non-catalytic for processes. Okay. The first thing that I would like to share is about the background. The global plastic production actually is around 368 million tons annually, 2021. So expected to double by 2040. And the environmental impact of plastic waste, it takes hundreds of years to degrade, and also significant contributor to marine and terrestrial pollution. Okay, what I'm gonna focus about of this study. My focus will be addressing polystyrene waste through pyrolysis. Okay, the polystyrene overview. The application of polystyrene, which is packaging, insulation, food containers, and etc. Widespread used to cost effectiveness and versatility. The recycling also statistics, only 10 to 15% of plastic waste is recycled. So PS has one of the lowest recycling rates among plastics. Okay. Now, a pyrolysis process overview. The definition is a thermal decomposition process in the absence of oxygen. And the advantages, the first thing or the first advantage is converts waste to energy or value-added products. So reduces dependency on fossil fuels. The pyrolysis products, we can say liquid oil, gas, and residue. Okay, the research objectives. Actually, it's to analyze thermal and catalytic pyrolysis of PS waste, and also to compare product yields and quality between the two processes. Also to evaluate the potential for sustainable PS waste management. Okay, the materials used, the types of polystyrene, which is expanded polystyrene (EPS), virgin polystyrene (VPS), high impact polystyrene (high IPS), polystyrene containers (CPS). The collection is what's collected from households, institutions, and packaging sources. And after that, the preparation, which is cleaning, shredding, and melting to reduce volume. As we can see here, in the table one, which is proximate and ultimate analysis of PS waste. So the proximate analysis, we have moisture as volatics, fixed carbon. The percentages for each one for moisture is 0.28%, for ash is 0.84%, and the volatile is 94.33%, and for fixed carbons is 4.55%. But for ultimate analysis, for measure is carbon, for ash is hydrogen, and for volatile is nitrogen, and for fixed carbons is sulfur. Also, the percentage after that for measure is 89.2%, for ash is 8.78%, and for volatile is 0.01%, and for fixed carbons is 0%. Okay, here for experimental setup. Actually, the reactor design, it will be a semi-batch stainless steel reactor, and the operating temperature is 500 degrees Celsius. After that, heating mechanism. So it's uniform heating at a rate of 20% per minute, and nitrogen flow to maintain an inert atmosphere. After that, the catalyst used. we have result based on catalyst for catalytic pyrolysis. And we can see here the reactor. So actually, I mean, or this diagram. Actually, this diagram depicts a pyrolysis reactor system for converting materials like polystyrene waste into liquid, gas, and sharp products. So the setup includes a furnace and reactor for thermal decomposition, regulated by a PID temperature, control and monitored by a thermocouple. So vapors excite the reactor to condenser where they are cooled into liquid. So it's collected in the liquid product collection unit, while gases are directed to a gas collection unit with a pressure gauge and release value. So a nice bath enhances condensation efficiency, ensuring optimal product recovery. Uh, Okay, for analytical techniques, proximate and ultimate analysis, so it's elemental composition, CHNS analysis, and posture, ash, and volatile matter. So for the thermal degradation study, which is the thermogravimetric analysis, TGA, at various heating rates. So for gas and liquid characterization, which is GCMS for composition, and gas chromatography for gases products. Now, thermal pyrolysis results. For the product yield, for liquid oil is 78%, which is the density is 0.875 gram per centimeter per 3. And the gas is 14%, which is methane, ether, propane. And the residue is 8%. The temperature impact degradation starts at 380 degrees Celsius, peaks around 500 degrees Celsius also. The challenge is limited control over product composition. Okay, now for catalytic pyrolysis results, the product yield is liquid oil 42 degrees Celsius, gas is 52 degrees Celsius, which is higher methane and ethane content. The residue is also 6%. Catalyst effect, faster reaction rates, improved gas selectivity and hydrocarbon quality. And for suitability, for fuel grade hydrocarbon reduction. Okay, now the comparison of gas compositions. The thermal pyrolysis, higher CO and CO2 content due to secondary reactions. So catalytic pyrolysis, higher methane, ethane, and propane content. As we can see here in the figure 4, which is gas analysis for catalytic and non-catalytic pyrolysis of PS waste or at 500 degrees Celsius. So it's the you have higher methane, ethane, and propane. Okay. Now for liquid oil characteristics, the thermal pyrolysis oil so is higher density, as I said before, is 0.875 gram per centimeter per 3, and wide range of hydrocarbons C5, C20. And the catalytic pyrolysis oil, the lower density is 0.745 gram per centimeter per 3, and the narrower hydrocarbon range C5, C10. The applications are thermal industrial heating and catalytic gasoline-like fuels. Now for environmental impact. The reduction in plastic waste converts non-recyclable PS waste into usable products, lower carbon emissions. Lower carbon emissions, which is compared to direct incineration, and also renewable energy potential, which is promotes circular economy practices. Conclusion, thermal pyrolysis, which is a high liquid yield but less selective product. Catalytic pyrolysis, which is a better product quality for fuel applications. And for implications for waste management, which is viable alternative for non-recyclable PS waste. And future work is investigate alternative catalysts and also industrial scale feasibility studies. Thank you so much. That was for my presentation about catalytic and non-catalytic processes. If you have any question, please let me know. والسلام عليكم ورحمة الله وبركاته.